We have our next speaker, Sumir, with us. He'll be speaking about building your own VoIP system and call spoofing. He's a passionate about he's passionate about development, cybersecurity, and online privacy, who is now making an effort to build an online presence. He channels this passion into help building and breaking secure systems. He led the breach force community and volunteered with FOSS Mumbai. Without a further ado, let's get started with the talk. Please cheer up for Sumir. Thank you. The stage is all yours.
So, good morning, everyone. Today we're going to be covering phone systems and their security. We're going to cover from PBX systems to PSTN systems, while also having it shaken/stirred. If you're confused by the terms, don't worry, we're going to clear everything up real soon. So, about me, I am a developer at IndiaFOSS, and I also lead the breachforce community. You can also check us out on breachforce.net. We're a cybersecurity cohort based out of Mumbai, and if you're from Mumbai, we'd love to have you there at our next event. Disclaimer, this is very important. Doing this I'm showing theory. Please note that this is all for educational purposes. Doing this yourself can land you in jail for up to 3 years, unless you do a demo in public calling it research, in which case hopefully you're fine. Now, all the opinions and data I've shared here is of course of my own and not meant to reflect on my employer. I love an interactive session, so if you want, you can always raise your hand and ask a question in between. I do not mind. So let's start with a brief history on the phone systems, of course. Now, you would notice here there's a toy. This toy actually struck fear into the hearts of all telecom providers way back, way before computers became commonplace in our society. Basically, older phone systems used to use something called signaling system PHY, which used to use the same channel for processing your voice data and also for transmitting the signal data that defines where you're calling and who you're calling. This caused a real threat for people who were inquisitive and were trying to figure out how the system works. So they were using this whistle toy to blow in and basically use the 2600 Hertz range and change the caller ID or change who you're calling, which basically led to free international calling at the cost of the telecos, but giving any phone hobbyist the free ability. Some people are also doing it via whistling, so that's also a neat trick. A little bit of neat trivia here. This is a Bluebox. So the toy that I described, this is a digital version of it. It gave the end user more control, and they were able to just punch in the numbers of who they want to call and hack the phone system. Can anybody guess who created this first digital Bluebox? It was not Bill Gates, sorry. I heard another answer. What was it? Yes, Steve Jobs and Steve Wozniak. Whoever that was, round of applause to you. Before Apple, they were hacking the phone systems. Thank God they didn't get in trouble for it. Otherwise, we wouldn't have that Apple. So now let's cover how businesses create and bring their own systems, phone systems. So this is mostly required for example, if you're having a pizza shop, you want somebody to call into your pizza shop and get routed directly to your manager or the front desk person. And you also want your other employees to also have access to this phone network. That's why you tend to build these types of phone networks for businesses. For this, you use private branch exchange, which is basically, to equate it with network, it would be like your router. Every device or soft phone, as one end user would have, would basically be receiving an extension instead of an IP address for the phone system. So you can call between your internal system using extension numbers. You might have seen this in hotels or maybe in your society. You dial, for example, number 101 and call the flat number 101. All these type of methods are for the internal phone system. Now, to connect this with the public system, you use something called a SIP trunk, which is similar to an ISP but for the phone system. So the ISP connection basically allows you to make outbound calls and receive outbound calls. So for example, you can dial 9 and then type in the 10-digit number and make an outbound call to your friend. He can also dial the phone system of your PBX system, a phone number of your PBX system, and call you in directly. So simple example in illustrated as a diagram. You can see here your SIP provider. Basically, this is the one that's connecting you to the public telephone network here. And this is the company's PBX system, for which I would recommend freePBX. It's FOSS. Also, the end users here, all these people, they are basically going to be using SIP protocol phones, which are VoIP phones, soft phones. Recommendation for this would be linphone, which is again FOSS. And this allows you to connect to a public network, yes. So let's discuss about types of PBX systems. There are multiple types. Let's start with the very old analogous one, analog one, the legacy system. You might have seen in your society, there would be like 2 coaxial cables that connect to the phone system, and you can make phone calls with it. These are the old hardware-based systems that are more wire-based connections instead of using internet and IP-based connections. They are mostly obsolete. You will not be installing this anywhere anytime soon. At least I hope not. So next is the on-prem. This would be basically a hosted and managed one, where it can be a hardware-based or a software-based, and you will most likely be using VoIP systems, that is your IP-based, and purchasing of hardware and the additional maintenance can still be making it very expensive to do. Alternative is the hosted system, for example 3CX. They provide hosting services for your own PBX system. You can also be stuck in vendor lock-ins, so it's better to host your own and use freePBX or asterisk type systems instead. But they all have advanced VoIP features and you don't have to worry about scaling, so that's one aspect. Last is the hybrid system, which uses SIP trunks. That is your, you can have the IP PBX system on your on-prem, or you can have it on the hosted, but you can have virtual or hardware-based, and it'll connect to the SIP trunk system, which is your gateway to the public phone network. So why businesses use call spoofing? So you can see here David, he's returning calls with a number 456. Even though he's the CEO, the customer will be not likely to pick up their call. That's because the customer is more, he knows about only the number 123. That's the regular call ID that they use to call to the incoming front desk. Now, because of this, the chances of your call being rejected are so high. That is why businesses tend to prefer a call spoofing method, where all of these characters, for example, like Alice here, she would also receive the caller ID 123 despite having her own number. This translation is mostly done by the SIP provider. Now we're going to talk about the most modern phone protocol that is widely used. That is the session initiation protocol. This was most widely adopted during the 1990s when people were switching to VoIP-based systems. Protocols that enable VoIP, there are 3 main ones that I would like to cover today. That's session initiation protocol. This basically is a text-based protocol, and it works over port 5060 on the UDP and TCP protocol. And it's the issue with this is it's only for initial authentication and negotiation. It doesn't cover the whole aspect, and it's not meant to. It's only for the initiation of the connection. Then for transmitting a voice data, you'd be using RTP, which is your real-time protocol. And if your provider is actually very conscious about security, they would be using SRTP, which prevents clear text data traffic. But as we'll see, go ahead, we'll find out what the issues are. Last but not least is the session description protocol. This basically allows you to manage and exchange what all types of media formats you're accepting, what all codecs you're accepting, what all encoding you're accepting, and tells the system between a call also. If there's a renegotiation of the codec, it allows you to renegotiate it using SDP, and you can transmit your voice data seamlessly. There will be no drops. So now I'm going to be using a soft phone, and I'm going to be calling my VoIP system here. I'm again using linphone, FOSS completely. You can see the call has been come. Let's just accepted this for now. Test, 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 test. Now let's see the network traffic with this. Test, 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 test. Now you can see here, first the invite went. So this invite is basically like the initiator of the SIP for protocol. We went from the for extension 302, that's my soft phone here, up to the PBX system. And you might notice that the very first request is received unauthorized response, which is it might seem a bit odd to you, but don't worry, this is part of the plan. Because the very next step, you'll see that this is basically used for digest-based authentication. So it passes the nonce value that it requires for the next SDP. So you can see here the username, password, URI, all these hashes are calculated with the nonce values and then sent for authentication. In the first request, this will not be present. Now, just to talk about some of the headers here. This call ID header is basically used for uniqueness. It's like a primary key. It can tell you which call is associated with what packets are associated with it. The call sequence, that is the C sequence here, it basically tells you the order at which this process is happening. So in case the packets are rearranged in order, you can use this call sequence ID to find out what is going on. Then you can see here that with my 2, I've specified which system I want to call. And since it's an eternal system, it's not going to be going through anything else. It'll just be hitting my phone system that's in my cloud, and then it'll hit the laptop here. So here we can see there are a few protocols being exchanged. Here we are also kind of telling what all we are accepting. Here is the originator IP address and extension details. Here's the connection details. There's all sorts of negotiations between. Max forwards here specifies the number of call forwarding you're willing to accept. 70 itself is quite high. Now this is when, so the 100 series of response codes are basically when the process is still, it's a provisional response basically. While the call I hadn't picked it up yet, that's why it was trying, and it was waiting for me to finally pick it up, and then it was negotiating the session. So you can see 200 OK once I picked up the call. And then as soon as I cut it, it sent a bye. Similarly for the ringing, 200. Now, this is a diagrammatic explanation of the same. User 1 and user 2 is my phone and my laptop here. Both of them had registered to the PBX system using a register method over port 5060. User 1 then basically sends the invite request as we had seen to the PBX system, and then the invite request is forwarded to the laptop here. Now let's come to shaken/stirred. This very Bond-sounding acronym is actually by design. Originally, there was only developed STIR, that is the Secure Telephone Identity Revisited, and then later Shaken was introduced by the alliance in US and Canada. Shaken is basically standing for signature-based handling of asserted information using tokens, which they've quietly shrunk down to Shaken here, as you can see by the highlighted portion. It is specifically made to provide caller ID identification. So this is basically requires a SIP trunk to provide a type of certificate. This is basically PKI, but for your phone system. So the SIP trunk provides the certificate saying, I know this is my customer, I trust them, and this is the caller ID they're spoofing with, they are coming with. So that's why if I know this caller ID, then I would give it a Class A rating. If I don't know the caller ID and I know the customer, then I would be a Class B rating. But if you don't even know the customer and don't even know the source of the call, and you don't know where it's coming from, then you get the lowest rating possible, that is the Class C rating. Right here. This is often for in case you're coming up with coming from an international gateway, your request, if it's being routed through that, or if it's going through a legacy system, then you get a Class C rating. Now we're going to quickly cover a SIP invite header. So often when I would make a call to the public phone telephone network, you would see that this identity header highlighted here. This identity header may look familiar to some of you. It's basically a JWT token. In the first section, we're basically talking about who our provider is, what algorithms we're supporting, and we're providing the URL to the certificate that is of the provider. In the second section, we're talking about the attestation, that is A level, that's the highest level. We talk about the destination, who we're trying to reach, the originating phone call, and we also provide the cryptographic signature. This is important so that it's if anybody tries to change the packet data, the signature won't match, and you can easily detect that's a false. Now that we've covered the security solutions, let's break them. Over here, you're going to see that I'm going to call a friend of mine based in the US. Hi guys, 1 minute. So when we were connecting to the phone system, you would notice that we had set up a SIP trunk provider first. So this is the trunk provider. This basically allows you to connect your local PBX system to the telecom network. So here, for example, I've defined in Twilio. I've specified the caller ID that I want to use. You can do this at various levels. For example, the trunk level, the route level, or the extension level. So using this, you can also define rules that you want to set with. For example, for outbound routes, I've defined that I want to use this caller ID. Sorry. And you can also do this at the extension level. So you can see that these levels are tapering. So the topmost level you can do the most explicit configuration at. So let's take a look at extension 302, for example. Here I've defined all the what all outbound routes I wanted to use in the outbound route section and what trunks I needed for. Let's get back to the So now what we're going to try to do is call the external network and call my friends here. So Shalom, could you please turn on your screen, camera? So this is my friend, she's in the US, and we're going to spoof a caller ID and send it to her. If you're wondering why in the US, trust me, you do not want to mess with the TRAI in India. So let's go ahead. Now, can somebody in the audience tell me any US state that they know? Texas, okay, I hear Texas. Right now we're trying to basically replicate a US based number. Now, can anybody shout out a number they like? 7, okay. Another number. 3, my favorite number, nice. Another number. 9, okay. One more. 0, 2, what? Huh? 34, okay. This guy took both numbers, alright, 34. Let's just check the number of digits. 2, 3. Okay, good. We can copy this and show what it will look like. So this is apparently based in San Antonio and Chicago. I don't know how that's possible, but sure. I'm just going to call you with that number now. Okay, we could hear that she's received. Shalom, could you show your caller ID? Oh my God. Shalom, I'm just going to call you again once more. Yeah. Oh wait, I didn't apply configuration, sorry. Just one sec. So this basically what I did earlier, I tried to take her friend's number and I made it look like I'm calling her. That. Yeah.
When you have finished recording,
Basically, we made an outbound call. Let's rejoin. Sorry. So this is the number we had set. Let's compare. Okay. 201 73 and 34. Great. Sure. Thanks. Cut the wrong call. That's sure. Now I'm going to call another friend of mine, Fauzan. Do you mind turning on your camera? Hey. So I'm just going to give you a quick call.
I'm sorry, your simultaneous call limit.
Oh, wait. There's 2 calls going on. Yeah. Thanks for that. Yeah. So sometimes a caller frauds go. For example, here we had. Let me just cut this call.
The Google Fi Wireless subscriber you have called is not available. Please leave a message after the tone.
That's all. So oftentimes when you see a fraud score this high, for example, we had gotten 85 here, your phone would tend to highlight this as a potential risk. And oftentimes you would see a red banner telling you that this is a potential fraud. But in our case, we were able to spoof it perfectly. So great. We managed to do it. It was awesome. And now we're just going to, this is the diagram for the same. So that basically, we again authenticated ourselves with the register request to the phone system. And then with the extension 4003, 1 second. With the extension 4003, that is my laptop, we were able to call and send outbound call through the SIP trunk. Now the SIP trunk, because it was not able to authenticate me, because I haven't done KYC, and I also haven't done any type of source origination or any type of identity provided. So that's why they were giving me Class C rating. Now you can see the PSTN network still forwarded my call to my friends, and they were able to get the spoofed caller ID. Now let's talk about some of the issues with our current system. Oftentimes you would see the providers, they don't care about the security aspect so much, so they don't even bother applying the basic hygiene of basically using communication over TLS. It's all clear text. Like you can see if I was to intercept any of your phones, I could easily see the traffic, who you're calling, what you're talking about, all of that can be easily intercepted. Then you would often see that these caller, basically they have defined complete trust on the outbound caller ID, which is another bad practice. Like the providers, they don't even try to verify majority of the times who is actually calling us. Of course, there are protection mechanisms in place such as those shaken, which is covered here, but they don't take care of legacy systems. For example, your old phones, if somebody's calling that phone and then the call is being forwarded to the next person, the issue happens is that the identity header gets dropped. Because it thinks, okay, I've received the call, now I just have to send it ahead. So it doesn't think about the authentication mechanism there, again causing your phone calls to fail. Stir shaken is also very expensive to maintain because it requires basically public key infrastructure for the phone systems. So that's not very cheap, and also doesn't take into global context well. So for example, Chinese or India, the relations may not be the best. So in that case, the calls that are happening by China, they would always give it an A rating, even though they don't trust the caller ID. These type of, and basically pushing the SIP providers in your country to take care of proper authentication mechanisms and blocking people is not being followed. Now, last slide, ways to protect yourself. Very first and foremost, you have to raise awareness amongst your family and friends. You have to report these type of fraudulent calls. I've provided the number for the same here. And you'll note that scammers often try to rush your decision making. You don't have to get into that. You just have to take a deep breath, ask probing questions, try to find out the person on the other end is truly somebody you know. And in certain cases, you can try to connect with them over email or over another medium just to verify everything's fine. The Indian government has also taken a lot of protections against this. For example, they might try to block any spoofed caller IDs from international gateways coming in with the domestic numbers, because in that case it does not make sense why it would fail the attestation, so they fail them. They also take care of, they are working with telcos to leverage AI and detect fraud-based activities. This is a glossary of keywords. You can also refer it on the article on the website, so I'll skip through this. And these are a list of people I want to thank. Thank you.
Thank you so much, Sumir.
We see a lot of scammers, right? The couriers, that FedEx scams and all. So how are those calls coming to the customers? When we try to call back, those numbers are not valid numbers. So can you explain the mechanism? Is it what tools and technologies possibly are being used by these scammers, and from which countries, if you have studied this data, because it's very prevalent today?
Yeah. So oftentimes they don't set up the inbound route to the system. For example, I just want to make calls to you, but I don't ever want to receive them. So in that case, they don't bother to set up the incoming aspect of the system, phone system. And for scammers, they often try to do these spoofing techniques. So in that case, the caller ID that you're receiving is also fake. So there's no way of verifying for an end user. You just have to be careful. For telcos, of course, they have their own protection mechanisms. The resources here will of course be shared. You can also scan this QR code. There's an article on breachforce.net on this very same topic. The presentation slides and my LinkedIn or whatever you require will be present there. Thank you guys.